angle of elevation of the Pyramid of the Sun. The Pyramid of the Sun is in the ancient Mexican city of, I don't know how to pronounce that, Teotihuacan. The base is a square with sides about 700 feet long. The height of the pyramid is about 200 feet. Find the angle of elevation of the edge indicated in the figure to two significant digits. All right, so there's the Pyramid of the Sun. Interesting. And so if the sides are about 700 feet, it's a square, the base is a square, and they know the height is about 200 feet, then what's the angle of elevation? What's the kind of the slope of the pyramid? Remember, angle of elevation and angle of depression are measured with respect to the horizontal. Angle of elevation is above the horizontal, angle of depression is below. All right, so if we've got a square, then what we're looking for is to get this angle. There's a right triangle here that we can reference, where the base of the triangle here is one of the legs, and that length is half of the diagonal length of the square base of the pyramid. So what is, if we can get that leg length, we've got this other leg, which is the height of the pyramid, then we could use the inverse of tangent, would be opposite over adjacent, to get the angle of elevation. So first, let's figure out what's this diagonal length here. So, okay, there's the base of the pyramid. Okay, so this is a right triangle. So we can use the Pythagorean theorem to get this length. We'll call this d for diagonal. So Pythagorean theorem, we know that this leg squared plus this leg squared is equal to the d squared. So d is 700 squared plus 700 squared, and then take the square root of that. So, okay, 700 squared, and then just multiply that times 2, right? And then take the square root of that, 700 root 2. So what we can do is, we're not focusing on significant digits much at all in this course, but, we can try and carry exact answers, or as accurate answers as possible, all the way to the end, and then we'll round it to two significant digits. Let's try and do that. So, okay, there's the diagonal. That's in feet. So, okay, now we'll call this just A, this length here. What is A? A is D divided by 2. Well, what is 700 divided by 2? That's 350. So A is 350 root 2 feet. All right. So now what we can do is we can say that we know that the tangent of that angle of elevation is what? Opposite over adjacent. So 200 divided by 350 root 2. So 20 divided by 5 is 4. 35 divided by 5 is 7. So tangent theta is equal to 4 over 7 root 2. We could rationalize this, why not? So tangent theta is equal to, so times root 2 divided by root 2, we've got 4 root 2 divided by, and this is going to be 7 times 2, and so you get, so tangent theta is equal to 2 root 2 divided by 7. All right, so what do we do with this? Well, we want to figure out for what angle theta does the tangent of theta equal this. And so this has to do with inverse trig functions, and we're going to study these in detail in a later chapter, but we've dipped our toe into this a little bit at this point. And what we do is we could use our calculator for this. So we go inverse. So there's the inverses. And we type in 2 root 2 divided by 7. Is that right? Now it can't give us an exact answer, so that means it's not one of the special angles, or it has a reference angle that's one of the special angles. So we get an approximate answer. Control enter, that's approximate. And so 22. And that will just round that to 22. So theta is equal to 22 degrees. We'll put approximately. Now, just note that, so these inverse functions are only going to give, we saw that when we did inverse examples, we saw that like within like 0 to 360 or 0 to minus 360, like within like one revolution, there's usually 2 possible angles that result in a certain value. And so, but the calculator is only going to give like the smallest of those. And so all you do is, in that scenario, you're going to have your problem, so you have an idea of what the angle is going to be. Like if this was an angle that we know it should be like in the 100 something range, or like, kind of an obtuse angle like in that range, then we would have gotten 22, but we would add 180 to it or subtract 180 to it based on the problem. Okay, and again, we're going to talk about inverse trig functions in detail in a later chapter.